Welcome back. We're going to start our first invited talk. And what an honor to introduce Orit Shaer. I've been a long-time big fan of her work. Orit Shaer is an associate professor of computer science at Wellesley College, where she directs the Human-Computer Interaction Lab. Her research focuses on novel human-computer interaction for the future of work and learning, including tangible and embodied interaction and mixed reality interfaces. She received many prestigious awards, including the NSF Career Award and various research from industry like Google. I'll hand the podium over to Orit to learn more about her impactful work.
Thank you. Thank you so much. This is such a pleasure to be here and to connect. I wish we could be in person and maybe next year. So I'm going to start by sharing my screen. Okay, is it shared correctly? Great. One second, get it all to work. Great. So I want to start just by kind of mentioning that Wellesley College, where I work, is a liberal arts college for women next to Boston. And this liberal arts approach, as well as kind of the women empowerment that kind of stands as kind of the central mission for Wellesley, is really important, not only for me as an educator, but also as a way to inform the research that I'm doing. So I thought I'll start with kind of just a snippet from a video about Wellesley to give you a sense of the place.
To never give up.
Never give up.
To never give up. Where my will to keep going will outgrow my fear of failure.
This is where I found my passion.
To undertake something so meaningful,
so audacious, and take it past the point of no return.
This is where I found my mission, my obligation, my calling. To do something positive, something remarkable, something good.
This is where I found my resolve.
And my ability to throw rocks straight up to shatter every glass ceiling.
Okay, great. So this is kind of my research lab. And as you can see, kind of most of the researchers are undergraduates, women working in the lab. They coming with different backgrounds. So we have students that coming from computer science, media art and science, psychology, biology, chemistry, education, philosophy, really bringing the liberal arts perspective into human-computer interaction research. And with the students, kind of my focus is working on tangible and embodied interaction. So in the last really 20 years, I've been working in the field. And in the last 5 years, I was working closely with Brie Gulmer, with Ali Mazalek, and with Caroline Hamels on creating a new book that explores kind of the technical foundations, the conceptual, cognitive, philosophical foundations of tangible and embodied interaction. And the book is finally currently in production and will be available on the ACM Digital Library soon. So hopefully people will be able to access it. And within this exciting growing field of tangible and embodied interaction, my focus was on exploring how tangible and embodied interaction can enhance collaboration and decision-making. And this is kind of the overarching question that I'm exploring. But in order to explore this question, I'm thinking about frameworks and technology for building and thinking about tangible and embodied interaction, developing interactive systems that address and accommodate different audiences, and thinking about evaluation methods, inventing new evaluation methods that will be able to assess the impact of these interactive systems. And I'm doing this work by looking at driving problems that typically come from disciplines outside of human-computer interaction. In particular, I'm intrigued by data-intense fields, such as biology. So today I'm going to give an overview of two kind of domain areas that I've been working with. The first one will be making the invisible tangible. And I will show some kind of a survey of interactive systems that we have been developing for different audiences working within the domain of biology. And then briefly, I will be talking about our research on new evaluation methods for enhancing understanding how we can enhance collaborative decision-making and creativity. So we start with biology, because this is a field that I've been thinking about really for the last 10 years. And my fascination with biological engineering and genomics come from the premise of this field, not only to transform medicine, but also to really address pressing problems such as food production, pollution, space exploration, and of course, immune development of vaccination. But this vast volume and the complexity of biological data sets make it challenging to scientists as well as for other audiences to turn data into insight. So machine learning has been taking important role in helping scientists to generate new insights, but so does information visualization and human-computer interaction. And just before I show some example, it's also important to highlight that scientists are not the only audience, they're not the only population of users who seek to explore and make sense of biological data. So today I'm going to show a work for scientists, with future scientists, college students and children, and with the general public. So one of my favorite projects and one of the first that I worked on in Wellesley College when I joined as junior faculty is Genome Surfer. And Genome Surfer is a tabletop genome browser that was aimed for helping novice scientists, so this will be undergraduate students or graduate students learning to work with bioinformatics, to sit together with a mentor or with collaborators to explore genomics data sets. And with this interface, they're able to locate a gene, learn what is currently known in the professional literature about this gene, retrieve either the DNA sequence or the protein sequence of this gene, annotate and compare genomic sequences. And it was implemented by now an archaeological artifact that was the first Microsoft Surface table that you're seeing here. And I'll play a quick video just to show the collaborative multi-touch interaction that we created for exploring genomic sequences. So here we see that users can search through professional data sets. They can retrieve and compare genomic and protein sequences. And they can use different and advanced bioinformatic tools. And they can do that within the collaborative environment of Genome Surfer. Then we worked closely with scientists, and in particular with a group of synthetic biologists in Boston University to develop MocoPlanner. And MocoPlanner is a collaborative tool for visualizing and for planning a process called molecular cloning. This is a process, really a set of experimental methods in biological engineering that is used to assemble DNA and to direct the replication within host organisms of particular sequence of DNA. And this is a complex sequence of experimental steps. It requires multi-step planning. And the symbols that you're seeing here are symbols that are coming from a visual language for synthetic biology that is called ESPO. And here again, we try to create as natural collaboration as possible that will use the power of information visualization to allow scientists to work together through this process of multi-step planning and experimentation. So they were creating a program and explore different combinations, and they were able to export that program through automatic compilation to the wet lab to power a robot that was able to handle liquids in order to print these pieces of DNA. We worked with future scientists working with children. So SynFlow is a museum exhibit that we created for the museum, for a museum in San Jose, California. This is an exhibit that is aimed at upper primary school, middle school kids and their parents and educators. And the goal was to allow children that don't have access to fully equipped science lab to interact with authentic artifacts from the lab to simulate a process, an experiment of biological engineering. So what children can do, they could kind of pick a block that represent a gene, and they could kind of transfer the gene into a plasmid, which is a small sequence of DNA. They could transfer that plasmid into a bacterial cell, and then they can introduce kind of a toxin, an environment stimulant, to check if that piece of DNA, of gene that was programmed to respond to particular toxin in the environment would trigger that particular piece of DNA. So what we try to accomplish here is to really use tangible interaction with authentic objects from the lab through as authentic gestures as we could to imitate the gestures of scientists in the lab, to allow children and adults to work together to figure out this scientific process. And here, of course, the 4 steps are really kind of simplified sequence, but they are authentic to the sequence that were applied in this original scientific experiment. So again, here's a short video that shows some of the interactions that kids could engage with. So this is a gene that would respond to a red environmental toxin. And now kind of the user is shaking to transfer it into a gene imitating the vortexing that is happening in the research lab. And here we see a bacterial cell that lives inside a Petri dish. And by mixing the liquids together, the gene will be transferred into this bacterial cell. And then kind of the visitors can test it. And we had multiple sets, so kids could work together to figure out the experimental steps and to make meaning out of this process. And I want to show very recent work. Again, interaction with biological information became important in our life during COVID-19 pandemic. So we were thinking how we can develop embodied interventions to help people adapt healthy behaviors. So we ran 2 remote experiments looking at embodied interventions that are delivered through the web camera and kind of augmented reality filters. In the picture on the left, you can see Ayana Seals, who is the PhD student from NYU leading this project. And she's demonstrating an intervention that teaches through animation how to wash hands according to the World Health Organization protocol. And what we're seeing here is in the center, the original animation that kind of follows the World Health Organization protocol, and then the hands of the users are kind of held, and you see kind of the dirt removed as the animation is playing. So you see, as you wash different areas of your hands on the animation, kind of the hands will reflect that process. And we deployed that intervention online through an unmoderated study in order to see what impact this intervention compared to the original animation and other intermediate conditions have on the risk perception and the intention to adopt hand washing behavior. And we did see a positive impact on intention. So there was significant impact on intention to repeat this protocol and adapt it in daily life. And that was mediated by kind of the perceived severity of the threat for that particular individual. So that study ran in August 2020 when kind of there was a lot of emphasis about hand washing as intervention to reduce the pandemic. And very recently, we were developing a similar intervention, this time taking animation that was developed by Scripps Research Lab of how the vaccine works, and taking that animation, and here you can see the original animation at the top, it presented on top of an avatar. And again, we took that animation and projected it on the user view, and we wanted to study two things: how it impact the internal risk attribution, whether the person attribute the risk to their own behavior or to external factors such as kind of society, government, town, environment. And what we've seen is that there was positive impact of the self-focused augmented reality and of the avatar for developing internal risk attribution, but not impacting the vaccine intention. So we published the results of the first study with the hand washing behavior, and we're currently working on continuing and analyzing and preparing the manuscript for the study about the vaccine animation. But again, kind of taking our knowledge and thinking how we can kind of create intervention that take tangible and embodied interaction, in this case, embodied interaction, to generate positive impact. So this was just a survey of some of the interactive systems that we were building using the lens of tangible and embodied interaction in order to expose different audiences to working with biological information. And what I want to kind of go to next is to show a project in which we focus on understanding how to enhance collaborative decision-making. And this is kind of collocated collaboration. Specifically, we were interested in how do users collaborate on complex decision-making tasks around a large-scale interactive surface. So we worked with a team of 8 users. So we were studying different teams of 8 users, and they were engaged in a collaborative decision-making that required them to first kind of adapt divergent thinking. So they had to go through multiple options, and then they had to converge and select a subset of options that they would like to recommend. And as they were going through this decision-making task, we were looking at visual attention, at the structure of collaboration, and of the spatial use of the surface. So I'm not going to go through the entire study. I just want to highlight specifically 2 new ways of assessing behavior that we developed. So here you see the interface that the user worked with, and you see that the surface is composed of 4 multi-taction devices connected together. There were 8 users that were interacting with the system, and each one of them could open a menu by through touch, explore different options that were organized by categories, and then kind of select particular cards of information. And the team together had to decide on a portfolio of 3 specific cards, 3 specific projects that they recommend to continue and explore. So when we started this investigation, it required intense video coding, and we were thinking, how can we use computational models in order to understand how users work together? So we used a kind of camera that was mounted just above the surface to look at the spatial interaction on the surface in order to understand the working style of this group. So here I'm going to play a sequence. You see, this is a group that work as an entire group together, and you can see kind of the heat map. And here's a different group that really kind of converged into working in pairs, and we get to see how the spatial interaction. Here's another group, and we had one group of 4 and 2 pairs that decided to work together. And it's easy from this technique to see how the interaction evolved by exploring the spatial interaction on the surface. We also looked to understand how visual attention indicate collaboration, and specifically we were looking for co-joint, kind of joint visual attentions of individuals working together on the same areas of the interface. So for this case, we had users wearing kind of a lightweight eye tracking device as they were interacting with the system. And here I can play a video that shows what the camera captured. And how we analyze the data. This is the interaction, and you see kind of the gaze data that was recorded with the hand mounted. So this is the gaze data before any processing. this is how it looks. After the processing, it recognized where in terms of an area of the surface where the users are looking, and we're particularly looking for joint attention. So what we're seeing here is each line is representing a user, and the line is kind of moving where there is joint attention. So here you can see that there were 4 users and they were working in pairs. So we see kind of that the green user and the purple user converge many times, and we see that kind of the purple, the red and the cyan users are working together. And this created an automatic timeline of the entire kind of 45 minutes of interaction. So we can see that in the beginning, they were checking with each other, and then they were working in pairs, and then kind of they moved on to check with each other again. And these 2 techniques helped us to make sense of how people work together in a relatively large team around an interactive surface. Then came COVID-19 and required us to adapt new ways of evaluating the impact of interfaces. So this is an overview of a 9 weeks longitudinal study that we conducted in order to understand the impact of virtual nature experiences on knowledge workers that are working from home during COVID-19. So this was a study that required us to really kind of redesign how do we work with user. This was a heavily moderated remote study of virtual reality. And we see that in the first 3 weeks, we ask users to check with us on a daily text message that required them to go through a creativity test. We use 2 different tasks to measure creativity. One of them is called the alternate users task, and it's focusing on divergent thinking. Another one is called the remote associate task, and it's looking at convergent thinking. So the first 3 weeks, there was no intervention, there was just daily check-in. Then kind of weeks 4 to 6, they experience nature in virtual reality and continue with the daily check-in. And then in week 7 to 9, we added mindfulness to the practice. And here you see kind of the 3 nature scenes that they could choose to engage with in virtual reality. And we conducted surveys every phase of the study, as well as an exit interview. I'm not going to present the findings. I really wanted to show kind of this new way of interacting with users in order to conduct a moderated remote study, but just kind of high level aspect of the result is that the users perceive the benefit of virtual experience to really kind of calm and relax them, and to provide an escape, and for some to help focus as well. And we did see an impact of the virtual reality combined with mindfulness on creativity, both in terms on convergent thinking as well as divergent thinking, and the subjective kind of feeling of being focused on the work. And this is still a manuscript in preparation. So I want to finish up just highlighting some thoughts from our book on tangible and embodied interaction, really talking about path forwards. And as we were concluding the book, which really happened in the midst of the pandemic, we were thinking, what are some call for actions for the tangible and embodied interaction communities? What directions would we like to see this community going? And specifically, we highlighted projects and directions that have to do with deep engagement with societal challenges and with the changing paradigms, right? Kind of engage with our changing paradigms of economy, of societal structures, of injustices, and think how tangible and embodied interaction, not only the products, but also the evaluation methods and the design processes could be engaging with these challenges. We thought about highlighting synergies across scientific, technical, and art and design across STEAM, which the field of tangible and embodied interaction values, and also how we can create artifacts, processes, and community that is kind of embedded in the social cultural structures and is inclusive. So I'm going to leave you with these thoughts. And I just want to thank the many students that were involved in this project and the funding, and I'm happy to answer questions.
Thank you, Orit, for the beautiful, inspiring talk. We already have some questions on our YouTube channel, so I'll take them. The first question is from Paul, who is asking, has your group explored interactions on large touch surfaces that involve cross collaboration with a team of in-person users on one device with a team of remote users on another device?
Not yet, but that's a great direction to go. I think that we're going to see how the future of work, bringing hybrid teams together. I think we should expect, especially if we read the announcement made by large companies, we should expect to see these hybrid teams in which some are working, co-collaborating with interactive surfaces, and some are being present in that space through other devices. So I think that that will be a really intriguing direction to go forward, and I do anticipate that we'll be focusing on that. What we're currently doing, another project that I didn't mention that is currently ongoing, is a project in which we're studying how teams work together on a creative task, again, creative decision-making task, using video calls. So we're looking specifically on how teams working together to, again, apply convergent and divergent thinking, and what is the impact of remote collaboration on that.
That's great. I have a question, a very general question, actually. So one of the things I like about your research is that you find actual real-world problem, and then you try to solve it using tangible and embodied interaction. Which is difficult. It sounds easy, but it's difficult because of the novelty and wow factor. So, people may have tendency of, just creating cool examples rather than trying to solve actual problems. So I just wanted to know your process of finding problems, and how do you figure out that tangible and embodied interaction would be a good fit to solve this problem?
That's a great question. Thank you for asking it. And it brings me back to kind of the video that I started with. We had some technical difficulties, but it was important for me to start with the video of Wellesley, kind of to demonstrate the different perspectives that students bring into the lab. Because working in an interdisciplinary environment really helps to engage with real world problems. I'm kind of surrounded by scientists living in the Wellesley College Science Center. I have students that are kind of working and double majoring and kind of bringing perspective, and that inspire me to kind of think about real problems, to engage with scientists in the cases of the interfaces that I show around biology, and to start and think how we can bring tangible and embodied interaction to solve them. And when we go through the process of prototyping to address real problem, it requires us to invest a lot of time in prototyping, because it's not just a feasibility prototype. It really needs to work so that we can study whether it is helpful for the scientist or the users. And then it requires different kinds of evaluation methods that involve deploying it in the wild. There is a novelty effect. So you can't show a demo to kind of a biologist and say, hey, so what do you think? Mm-hmm. You really have to let them use that to solve the problem that they care about over time. So whenever we assess the impact of a new interface, we typically deploy it in a research lab, or we deploy it in a class, a seminar class that uses it over a semester, in order to kind of make sure that we're not falling into kind of the novelty effect of these interfaces.
Thank you. Thank you for an excellent answer. I have another general question. We have tangible user interfaces and various tangible interaction techniques for about over 80 years now, I think. And we still don't see, this kind of interfaces and interactions around us. It's not ubiquitous yet. I was just wondering that, do you see ourselves, I'm not sure whether you watched Black Panther, where you have, like the chemo bits. It's bits that are tangible, and they can group them together to form some kind of shape. So it's mostly tangible interface, and it's ubiquitous in that culture. So just wondering, do you see ourselves going to that direction? Or is it going to be, like for special cases or special scenarios?
Yeah, I think that we see more and more tangible user interfaces in the wild. I think we see them in museums, we see them in educational settings. I believe strongly that we're going to see more of them in the workplace. And I think that many of the tangible user interfaces that we'll see will be domain specific. But at the same time, with new kind of shape-changing technologies, there are opportunities to explore more flexible, modular, self-assembling structures. And I'm very excited about that direction.
Great. Unfortunately, that's all the time we have for this talk. I'll give the podium to Ali, who'll introduce the next speaker.